We're rolling. Hey, I want to let you know, this is still page 217. This is part B. We've created this shape, probably a square. We've created this shape in circle O. So if you haven't done that yet, go back and watch part A. Also a reminder, this video is brought to you by the vocab word central angle. Get it? Central, and then angles in the middle. It's what goes from the center of the circle out to the edge. That's right, central angle. We're going to answer some questions about the circle and the shapes that we drew inside that figure. So take a minute to make sure you've got this. Go back and watch the previous video so it's made precisely. Hence, I used tracing paper to do that. Something that I need to comment on right now is I need to add some information. The one thing that I know for sure is that this is a 90-degree angle because they were meant to be created perpendicular to each other. So that's also 90, that's also 90, that's also 90. Furthermore, if you go from the center of a circle out to the edge of the circle, that line is a radius. And I'm going to put a little spike on it because go the other direction from O to R, that's also a radius, and all of the radii of a circle are the same length, which means OV gets a spike and OW gets a spike. Now we talked about this enough, but maybe not enough. Here's a triangle made with lines that are, spike and spike and a 90-degree angle in the middle. That's triangle QOW. Then there's another triangle, ROW, with a spike, a 90-degree angle, and a spike. I would imagine, and I hope you understand this, this triangle is exactly the same as this one because they're made the same way. They have lines that are the same length. They have an angle between them that's the same measurement. So therefore, they are the same triangle size. They are, geometry word, congruent. Do the same thing for QOV, the triangle made with point Q, point O, point V. That line has a spike. That line has a spike. There's a 90-degree angle in the middle. So this triangle is the same as those triangles. And let's see if I can hunt for a good color. How about red? So we've got a last triangle, ROV, or VOR. You can switch the letters around. But this line right here that has a spike, and this line right here that has a spike, and it has an angle between them, that means this triangle is the same as the blue triangle, ROW, the green triangle, QOW, and the orange triangle, QOV. They're all the same triangle. Guess what that means? Guess what that means? That means that RV gets 2 spikes, maybe with a pencil, and RW gets 2 spikes, and QW gets 2 spikes, and QV gets 2 spikes. Has to be 2 spikes because we've already used a 1-spike line. But they're all the same distance. Because if this triangle is the same as this one, is the same as this one, is the same as this one, then all of the outside sides, 2 spike, 2 spike, 2 spike, 2 spike, they're all the same. You have drawn 4 triangles. Use these triangles to analyze the lengths of each side of the quadrilateral. What do you notice? They're all equal. The outside, I don't like the word outside. I'm sorry, I'm erasing it. The lengths of each side, I don't even like the way that I'm saying this. I'm gonna cut directly to the answer that I want to use. The triangles are all congruent by SAS. Triangles are all congruent. By the way, this is the symbol for congruent, the little equal sign with the tilde squiggle above it. The triangles are all congruent by SAS. So that means QV is the same or congruent to VR, congruent to RW, congruent to WQ. That's all the way around the square. That means that we have at least a rhombus. Determine the measure of each interior angle of the quadrilateral. So to do that, I'm going to kind of use a cheat code, and I'm going to say that this patty paper here, let me kind of enunciate the corner, right? Here it is. This patty paper, The corner of the piece of patty paper is perfectly 90 degrees. So if I take, and I can also prove it with a protractor, right? You measure it, you see, look, 0, 0, 90. The corner of a piece of patty paper is 90. So if I push this up into the shape right here, so like right there, that's a 90-degree angle at V. That's a 90-degree angle at R. That's a 90-degree angle at W. And that's a 90-degree angle at Q. So by doing that, determining the measure of each interior angle, that means that the measure of angle QVR, pay attention to the middle letter, QVR is 90 degrees. The measure of angle VRW is 90 degrees. Once again, pay attention to the middle letter. That's angle R, but it's the 3 letters that we need. The measure of angle RWQ is 90 degrees. Again, pay attention to the middle letter. That's angle W. It's a 90-degree angle. And the measure of angle WQV is 90 degrees. Paying attention to the middle letter, we've got all 4 corners of that box are 90 degrees. If the sides are the same, if the angles are the same and they're 90, then what name can you use to describe this quadrilateral? The most specific name for this is a square. But a square is a special type of rhombus because all of the sides are the same. A square is also a special type of rectangle because all of the angles are 90 degrees. A square is a special type of parallelogram because opposite sides are parallel. And that means it's also a special type of quadrilateral. All right. Thanks for watching page 217. Turn the page. Let's go to page 218. Bye.